On the more optimization, so I know we did this last time, but basically, so it says find two positive numbers that minimize the sum of twice the first number plus the second number. So we're saying like our two numbers are x and y. So our sum is going to be twice the first number plus the second number, so y, and the product of those two numbers is 288. So hopefully you guys set it up like that. So the x times y equals 288 is your secondary equation, and it allows you to solve for one of the variables, for y. So we get s equals 2x plus 288 over x, I'm going to write x to the negative 1. So when we take the derivative, we get 2 minus 288 x to the negative 2. So we can get common denominators. So we're going to multiply this first one by x squared over x squared. So we're going to get 2x squared minus 288 all over x squared. So when we set them each equal to 0, the numerator and the denominator, we end up getting x equals plus or minus 12 and x equals 0 as our critical values. Okay, but we want two positive numbers, and the 0 is actually minimizing the sum. So we actually, if you check them, you end up getting 12 and 24 as your answer. So you want 2 times 12 plus 24 to minimize the sum. Or I guess I said the 0 is the one that maximizes. But if you had done 0, then you would have had 2 times 0, and then the other number, well, how do you do that, right? It doesn't work, actually. So you can't do that one. So yeah, your answers are going to be 12 and 24. Did you all do this little number line thing where you checked? Yeah. Did you make sure that that was the? You should make sure that it is indeed the minimum. So if you try like 1 into the derivative, you get a negative on top, positive on bottom. And then if you try like 13, you get positive, positive. So down and then up. So yeah, that is the minimum for the sum. All right. Let's try the next one. All right, so on this one, so it says an open box is to be made from a piece of metal that's 16 by 30 by cutting squares of equal size. So we did one kind of like this the other day. So when we were finding the volume of the box, this whole distance here was 30. So this distance in here is going to be 30 minus 2x. All right, and then the same thing for the other. You know, it was 16 originally, so it's going to be 16 minus 2x. And then when you fold it up, the distance that you're folding up ends up being x. Okay, so you're going to have that as your original equation. And you should multiply it out. So when you FOIL it out and then multiply the x in, so I'm going to skip some steps, I got to 4x cubed minus 92x squared plus 480x. Did you guys get that? So now you take the derivative. So you have 12x squared minus 184x, oops, 184x plus 480, and you set it equal to 0. Okay, you can't actually pull out a 12. You can factor, but it's a little bit hard to factor. So some of you guys probably used quadratic formula. Did you guys do quadratic formula? So if you do your quadratic formula, you end up getting to the point where you have like 184 plus or minus the square root of 10,816 over 24. So you get two values. You get 12 and you get 3.3 repeating. Okay, so this is how much you're cutting out in inches from each piece. Okay, however, you can't cut out 12, right? Doesn't work. So when you verify with V prime to see if the 3.3 repeating works, it's really kind of closed between 0 and 12. Because 12 is the biggest amount, well, you wouldn't even be able to pull up, do 12. How much could you cut out from each corner? What would be too much, I guess I should say? 8. Do you guys see that? Because you have a side that's 16. So 8 is really kind of like your endpoint there. So if you try like 1 into the derivative, you end up getting positive. And if you try like, I don't know, like 5, you get a negative. Is that right? You guys check that. So if you check in the derivative. So you end up getting a maximum volume. So the 3.3 is how much you're, so when it says what size of square should be cut out, that's what that is. For the size of the square. And then it says, well, what is the maximum volume? So go back here to your original equation and plug that answer in. So I would be very careful with your decimals. So I would keep that stored, or I would write it as 10 over 3 as you're plugging it in, right? So you should get the maximum volume, 725.926 cubic inches, okay? what groups got that right. All right, so number 3, I'm going to kind of talk about really quickly. This is actually, it's kind of a cool problem. This is actually what dogs will do. So dogs innately know to do this. So if a dog is in the water, and let's say they're trying to get to their owner or something. They see their owner there, and the owner's holding up a treat. What they'll do is they'll take the, they'll kind of swim for a little bit on a diagonal, and then they'll run along the beach or whatever, the shoreline. Isn't that weird? So they actually do the maximizing. Crazy. All right, so anyway, I know, it's crazy. All right, so it says you're swimming in the ocean 1 mile from the shore, and you wish to get a town that's 3 miles down the coast, which is extremely rocky. You will need to swim to the shore and then possibly walk along the rocky coastline. So walking, I mean, you're still going faster walking, but you're not going much faster. So I like how I have all these typos. What point would you swim to along the shoreline so that the time it takes to get there is a minimum? I think I stole this from something else. Okay, it says you swim at 2 miles per hour and you hike along the rocks at 4 miles per hour. All right, so here's my hint to you before you guys try this problem. You guys know the distance formula, not the square root of x squared or x2 minus x1, that one. But you guys know distance is equal to what? Now you're like, I can only think of the distance rate times time, right? So if you're trying to minimize the time, so the time to take is a minimum, you're going to need to think about the distance that you traveled divided by the rate that you're traveling. Okay, so when you have 2 miles per hour and 4 miles per hour, you're actually going to have 1/2 and 1/4 in your problem because of that. Okay, so that's going to be my hint. So think about how you can maybe plug in a y here. Think about what y would equal. If you have 1 and x, the right triangle, how would you do this problem? So go ahead and try it. If you need to use your calculator to help you after you find the derivative, you can. Give me a second to try it. All right, so on this problem, so I gave you a hint. So the distance equals rate times time. All right, so if I'm coming up with what y is equal to, y squared is equal to 1 squared plus x squared. So y ends up being the square root of 1 plus x squared. So you're going to swim for that long, right? And your rate when you're swimming is 2 miles per hour. So you're going to have distance divided by rate. So distance divided by rate is going to be like that. And then your amount that you're walking is going to be the rest of that distance. So if we had x here, then this ends up being 3 minus x. So we're going to go a distance of 3 minus x, and its rate is going to be 4 miles per hour. So this is going to represent the total time. So I'll call it t for time. So a little bit messy, but let's kind of rewrite it so we can easily take the derivative. So I'm going to bring that 4 into both pieces. So I'm going to write like that. So when I take the derivative, I have t prime equals negative 1/4, 1 plus x squared to the negative, what did I do here? Oh, this should be plus 1/2. I was already skipping to the derivative. You should have been quicker. So positive 1/4, then to the negative 1/2, and then we have minus 1/4 there. So as we combine, we're going to have a 4 on the bottom. Oh, I forgot my chain, 2x. Man. Whoa, you could have gotten so many bonus points there. All right, 1 plus x squared, and then we have 2x minus 1/4. So we have that.
Oh, yes.
Okay, did you guys get to that point? All right. So we get common denominators. So we multiply by 1 plus x squared under square root 1 plus x squared, right? So when we combine, we have 2x minus the square root of 1 plus x squared all over 4 times the square root of 1 plus x squared. So when we get our critical values from the top and the bottom has nothing, right? No critical values from there. The top, you can find without a calculator by setting this equal to 0, adding the square root part over. You guys remember doing this type of stuff in Algebra 2? Squaring both sides, and so on. So you have 4x squared equals 1 plus x squared, so 3x squared equals 1. So you get x equals the square root, so plus or minus, but it would really just be plus because that distance, right? So square root of 1/3, which is 0.577 miles. So 2 groups got it correct. All right, so the two groups that got a correct.
No, say it loud, please.
All right, so you can't assume that it's a square. Some of you guys, I think, just assume that it was a square, which it actually is, but you really shouldn't. All right, so you should show the work, especially on the AP test when you get points. You know, if it's out of 8 points and you're only getting 1 point for your answer, that's probably not good. All right, so the first thing that we know is that the radius is 4. So this whole distance here is 8. So we're going to have x squared plus y squared equals 8 squared. So if I want to solve for one of the variables, let's say I solve for y, I get y equals the square root of 64 minus x squared. So it gets a little messy for a little bit because you're finding the area of the rectangle, which is just x times y. But you have x times the square root of 64 minus x squared, which is kind of hard to find the derivative of. You're definitely going to need to use the product rule and then also the chain rule, right? So we're going to take the derivative. So a prime is going to be first times the derivative of the second is 1/2 64 minus x squared to the negative 1/2 times the chain is negative 2x plus the derivative of the first is 1, and then you're just going to have the 64 minus x squared to the 1/2. Okay? So we clean it up a bit, and like the 1/2 and the 2 reduce out, but you still have a negative 1 there. So you're going to have negative x squared over the square root of 64 minus x squared plus the square root of 64 minus x squared. So you get common denominators. So multiply. So did you guys all get to this point? You understand what I'm doing? So when you combine the top, you have 64 minus x squared minus another x squared. So minus 2x squared. And on the bottom, you have the square root of 64 minus x squared. So who can tell me the critical values from the denominator? It's very easy. X equals 8 and negative 8. But you can't have negative 8, right? So 8. And basically that's saying, you know, if x was 8, then you don't actually have a triangle at all. It's just a straight like line. The hypotenuse is the length. So then we get the critical number from up here. And so when we set 64 minus 2x squared equal to 0, we end up getting x squared equals 32. I will say I was a little bit sad that only one group simplified this correctly. So the square root of 32 simplifies to 4 root 2. Many of you guys had things with root 8 or root 32 or whatever. You should simplify, right? So 4 root 2. And when you plug back in to find y, it actually ends up that y is also 4 root 2. And that will happen a lot in optimizations. A lot of times, if you had no idea how to do the problem, guess that it's a square, or guess that it's a 45, 45, 90 triangle, or whatever. Okay, but that's not, guessing's not the best in calculus. All right? All right, now I'm going to give you guys a hint for number 5. It's a little bit weird. Okay, this is taken from your textbook, I believe. All right, so here it goes. So it says 4 feet. 4 feet of wire is to be used to form a square in a circle. So, you know, you have a spool of 4 feet of wire here, and you're unrolling it, or unraveling it, and you're getting a giant square made out of wire, and you're getting a giant circle made out of wire. And together, those distances around make 4 feet. Does that make sense? So this whole distance here plus this whole distance here has to be all of the wire. We're using all of that wire to create this. It's a weird problem. All right, so that's going to give you your first equation, your, we call it the secondary equation, the equation that allows you to solve for the x or the y. Okay, but what you're maximizing, it says how much of the wire should be used for the square and how much should be used for the circle to enclose the maximum total area. That is talking about the area of both things together. So the area of the square and the area of the circle together. It might be that maybe you need none of the circle or none of the square, and you only use one of them. You have to figure that out. Okay, does that make sense? So think about what your 2 equations would be and which one you are going to take the derivative of. So that's my hint. So think about that one. There we go. All right, so it says 4 feet of wire is to be used to form a square and or a circle. So it could be just the square, just the circle, or both. So how much of the wire should be used for the square and how much should be used to enclose the circle to have the maximum total area? So I told you guys that the first thing is you're using all 4 feet. And you're going to use it for the perimeter of the square, which would be 4x, and the circumference of the circle, which is 2 pi r. Okay, so we have both of those. All right, that's going to allow you to solve for either x or r. So I found it was easier to solve so that I had r equal something. You can do it either way, though. So if you didn't do it this way, that's fine. All right, so we're trying to find the maximum total area. So the area is going to be x squared plus 2 pi, no, not 2 pi, what am I talking about? Pi r squared. It's like that, right? So we have the area of a square plus the area of a circle. So it's going to be x squared plus pi times, and I'm going to reduce this, I guess. So I'm going to have 2 minus 2x over pi. So I'm going to have 2 minus 2x over pi squared. So I'm multiplying. All right, so when I multiply that out, I get x squared plus pi. And then I'm going to FOIL the top. It's going to be over pi squared. So when I FOIL the top, I get 4 minus 8x plus 4x squared. Okay, and then the pi and the pi squared will reduce down to 1 pi on the bottom. So it's kind of messy. Are you guys like panicking in the middle of the problem, like what is going on here? There's so many pi's and x's. It's a lot to keep track of. So I went ahead and I brought the pi into each piece. So now when I take the derivative is going to be 2x. 4 over pi is a number. So I'm going to have minus 8 over pi plus 4 over pi times 2x. So I'm going to have 8 over pi x, like that. So pulling out the x's, getting this other part over here. So I'm going to have 8 over pi equals x times 2 plus 8 over pi. So when I divide it out, I get 8 over pi divided by, whoa, that's crazy, divided by. All right, divided by 2 plus 8 over pi, which is really gross. So it's easier to think of it as a decimal. So the decimal, when I found it, was 0.560. And I stored that because I rounded right there. So 0.560, okay? All right, so the frustrating thing sometimes about optimization problems is you really should do like the little sign chart. You should see if it's a maximum, if it's a minimum, what's happening, okay? So sometimes you should also, like if you're finding the absolute maximum, you need to check your endpoints as well. So worst case scenario, right, we would use 0 for x, or we would use 1 for x. Do you guys see where I got those numbers? So I would use, I would not make a square at all, and I'd have it all for the circle. Or I would only use the square, in which case it would be a 1 by 1 by 1 by 1 square. Do you guys see it? So x would be 1 in that case. All right, or x could be this 0.560, which we have. So I found what each of these things were for r. So I went ahead and I went back here and I plugged in to this equation for r to find out, you know, if x was 0, what would I get? So I'd have 2 over pi, which is around 0.637. So if you guys had solved for r, you probably had that number somewhere. And I thought, well, what's the area in each of those? So if I have that, and I add them together and I get the area, I get an area of 1.273. And I was like, well, what if I have the 0.560? When I solved for r, I ended up getting like 0.280. And when I found the area, it actually ended up being 0.560, the same as what x was. Okay, so that's not enough. So that one was actually like not working. It was the minimum. And then when I plug in 1, that means that I have 0 left for the radius. And I get 1 here. Okay, so which one is the maximum area then? This one, right? The 1.273. So that was in what? Feet? So square feet. All right, so that should be your answer. So basically you need x is 0, meaning for your square, you're not going to have a square at all. Right, it's going to be the entire circle. So we're going to have just the circle with radius equal to 0.637 feet. Okay, and that's the way to maximize. Weird, isn't it? See, that's why I always tell you guys to check endpoints for absolute max, absolute min and stuff. So you really should check endpoints for the optimization and do the number line, because sometimes there are really strange things, so we shouldn't shortcut it. All right?